myself, Alfred. I'm currently pursuing BTech in Artificial Intelligence and Data Science in the Department of Data Science and Cybersecurity in Cardinal University. Today, I will be demonstrating statistical interference. Before moving on to the question, I would like to tell what is statistical interference. It is a branch of statistics that uses data from a random sample to draw conclusions or inference about a much larger population. Let's move on to the questions. First question, calculate the population mean. This calculates the average, arithmetic average of all the age values in the data sets, treating the data sets itself as the entire population. See here, population of mean. It is showing 55.1590 of age. Next question, calculating the sample mean for n is equal to 100 and observe. The code demonstrates calculating the sample mean as an estimate for an population mean. Sample mean calculation. The code uses df_h.sample to draw the random. It is a function, small subset of 100 ages from the total population of 1000. Then it calculates the average of the sample. Let me run this code. See here. Sample mean of n is equal to 10 ages 52.45 something. Population mean of age is 55%. Next, calculate the average sample of n is equal to 1000 and observe. Here we are calculating the sample mean when the sample size is equal to the population size. N is equal to 1000 and n is equal to 1000. There n is equal to 100. So you can understand the difference between both the questions. This code takes a sample of n,000. So the total data set size is also 1000. The sample is in fact the entire population. Let me run this code. See a sample mean n is equal to 1000. If n is equal to 1000, it is 55.1590. If n is equal to 100, it is 52.450. Next question. Calculate the correlation using Pearson coefficient. The code evaluates the correlation coefficient, which quantifies the strength and direction of the linear relationship between two numerical variables, age and BMI. Here we are calculating the age and the BMI for correlations. See here, correlation matrix of age and BMI. Next question, calculate the correlation coefficient using BMI. The code calculates the rank correlation coefficient, which makes the strength and directions of monotonic relationship. How consistently two variables increases or decreases together based on their ranked variables. See here, correlation matrix. It is a Spearman correlation coefficient. That is a Pearson correlation coefficient. Next question, calculate the covariance matrix. The code calculates the covariance matrix, which shows how two numerical variables vary together, which means the age and BMI. See how there is vary together, age and BMI. Here we are taking both as two numerical values. Perform hypothesis testing with z-test. The code performs two sample z-tests to determine if the mean age of two random large samples are statistically different. I run this code. See a sample of A and sample of B and z statistics and p-value. Move on to the next question. Calculate the confidence interval. The code calculates 90% of confidence interval for the population mean age, demonstrating a common method for interval estimation. See here, sample mean and standard error of the mean, 90% of confidence interval of the mean. This is our answer of this question. Change the confidence level and observe the confidence interval. The code compares the 95% and 99% confidence intervals to illustrate the trade-off between confidence and precision. Confidence interval calculation. The code uses the age data to calculate two different confidence intervals, one at 95% and another at 99%. Let me run this code. So see here, it is a sample mean and age and n is equal to 1000. 99 of confidence level is these things. and 99 of confidence interval is this. Next question. Calculate the confidence intervals for 25 trials and upstream. The code stimulates drawing 25 random space, which means n is equal to 100 for each, from the population and calculates the 95% of confidence intervals for the mean of each sample, then checks if the true population mean is 55.159 is captured by the interval. Let me run this code. So see here, population mean of age is 55.1590. Say confidence in terms of 25 trials when n is equal to 100, it shows the trial sample mean, lower bound, upper bound, and contains population dot mean. And total trials is 25. And intervals that did not contain the population mean is also 2. Thank you. This is by Alpha now. My register number is CRK24AI1035.